Let's talk about factor by grouping. Factor by grouping happens an actual decent amount once you get into advanced algebra, algebra 3, algebra 4. And basically all factor by grouping is instead of just factoring out like a monomial, a 5 or a 6x squared, we're actually going to factor out a group of terms. And most times they're in parentheses. And so factoring out a group of terms is the same as factoring a monomial. It's just you have to continue to make sure that whatever terms you're looking at, they all have that group of symbols. So for instance, we do a couple easy ones here. Here, you notice we have this expression, and we have two terms. Okay, we have this one right here, and we have this one right here. And you notice they both have this x plus 1. So that means I could factor out that x plus 1. So I'm going to take this x plus 1 out. And then when I do that, so when I take this x plus 1 away from this, what do I have? I have an a. When I take an x plus 1 away from this, I have 10. And there you go. I just factored by grouping. Now you might be thinking, well, is that really the same thing? Well, sure. If I go ahead and if I were to FOIL all this, so if I were to distribute, I'd get ax plus 10x. Here I'd get a, and here I'd get 10. Okay. Over here, if I were to go ahead and distribute here, I'd get ax plus a, and here I'd get 10x plus 10. Okay, while the order is different, it doesn't make a difference. Remember, commutative property of addition says order doesn't make a difference in addition. But we essentially had the same thing. Okay, so these are identical to each other. So let's look at another one. So here you notice we have three terms. And they all have an a plus 2. So I'm going to take an a plus 2 out of all of them. So when I take an a plus 2 away from this, I have x squared. A plus 2 away from this, I have 5x. And a plus 2 from here, I have 4. Okay, so I just did some factor by grouping. But what you hopefully notice is this can factor more. A plus 2, and this will factor to be x plus 4 times x plus 1. Remember, again, we said this before, and that is when you're asked to factor, the assumption is you're going to factor completely. Okay, well, they're not always quite that easy. So let's take a look at this one right here. Now, factor by grouping does take a little bit of guess and check sometimes on how to come up with their factor by grouping. Up to this point, you notice we have this x to the third here. This would be a polynomial that, up to this point, we wouldn't really know how to factor, because you notice there isn't a common x or a common coefficient amongst all of them. So there's nothing you could factor out. It's not a trinomial, so we can't factor like we normally do. But what I'm going to do is I'm going to take a look at this thing, and I'm going to kind of split it up into two parts. I'm going to take a look at the first two terms. And I notice that in the first two terms, they both have at least an x squared. So I'm actually going to factor out an x squared out of the first two terms. So then I have x, and I have 2. And then in the second two terms, you notice that 5 is divisible both into 5x and 10. So I'm actually going to factor out a 5. So I get x plus 2. And what you'll notice, the result is now I have an x plus 2 common amongst both of these terms here. So I'm going to actually factor that out. So I'm going to take the x plus 2 out. And when I do that, when I take an x plus 2 away from this, I have x squared. Take an x plus 2 from this, I have 5. And this doesn't factor more, so I'm done. There you go. Okay. This is exactly the same as this. If you were to go through and FOIL this out, you'd end right back up here. Okay, and that's factor by grouping. Sometimes it takes a little bit of thought about, okay, well, let's look at part of the polynomial, okay, and this part of the polynomial and see if we can factor out. And sometimes it does take a little bit of guess and check on your part, a little bit of effort. Okay, so let's do another one. Let's kind of follow the same sort of advice here. So as I look at this one, I notice that here I have both these terms have at least they have a 2x squared. So I'm actually going to take a 2x squared out this time. So when I do that, I have an x minus 2 left over. Okay, now this part is a little different here because it says minus right here. The last one we did said plus. Okay, now I'm going to factor something out, but let's be intelligent about this. When we factor something out, what we're going to want to have left over is an x minus 2. So if I look at this and I notice I can take out a 3, okay, but the problem is I'll be left with an x plus 2. So what I'm going to do is I'm going to factor out a negative 3. So when I factor out a negative 3 from this, I just have x. I take a negative 3 from positive 6, I have negative 2 left. And from there, you notice now I have these are the same. So I'm actually going to factor the x minus 2 out. And then I have 2x squared minus 3 left over. And there you go. Factor by grouping. Okay, so one of the last ones that we're going to do, here's another factor by grouping. It's different than the other ones we've done so far. So far, what we have done is we grouped the first two terms together and the second two terms together. And this time, we could do that again. In the first two terms, you notice you could take out an x. These two you could group together, and you notice it's actually a difference of 2 squares, so you could factor that too. But the problem with doing that is that you're not going to get common factors like you did up here, okay, or up here. So another strategy is to look at the first 3 terms. So let's look at those first 3 terms. And what do you notice about these first 3 terms? Well, those first 3 terms make up a trinomial, and I could actually factor that trinomial. So I'm going to try and do that. So x and x, and then I'm going to use factors of 9y squared. I'm going to use minus 3y and minus 3y. And I'll just bring this minus 64 down. Okay, now that doesn't seem to do a lot for us yet, but notice these are the same because this is a perfect square trinomial, so it gives us the same factor twice. So I'm just going to write it as x minus 3y quantity squared minus 64. Okay, now what do you notice about that? Well, that is a difference of 2 squares. It's perfect square, and a minus sign. So it's a difference of 2 squares. So I can factor that. So remember, when we factor the difference of 2 squares, one's going to be plus, the other one's going to be minus. And then you're using the square roots of these. So the square root of the quantity of x minus 3y squared is just x minus 3y. Square root of 64 is 8. And then the square root of this again is x minus 3y. Square root of this is 8. And there you go. I just factored this. So definitely a different strategy here. By grouping, okay, remember it's factor by grouping, so we are grouping the first 3 together and factoring, versus the other ones where we group the first 2 together. Okay, so you have to kind of be aware of that. If the grouping the first 2 and the second 2 doesn't work, you might want to look at grouping those first 3. And there's even times where you would factor the second, group the second 3 together. Okay, so there's definitely some variations, but you need to just pay attention to that. Okay, so hopefully that made sense. That is factor by grouping.